In this lesson, we're going to look at a little bit of vocabulary for three-dimensional figures, and then what nets are, and then finding area of a sector of a circle. So we have kind of in our pre-volume stuff looked at what a face, an edge, and a vertex are. And so remember that face is kind of that flat surface, and edge is, where those faces meet. And then a vertex is kind of where all of three or more edges kind of intersect at a point. So we have some solid figures here. We have a prism, and we call those prisms more specifically named based upon their base shape. So kind of the top and the bottom that match up kind of the same shape, we call those the bases, and that's how we name those. Same thing kind of with a pyramid, depending upon the shape of its base. But pyramid kind of coming up to a point there with three or more triangular faces. A cylinder, kind of that curved, connected with two circular bases. A cone, one circular base coming up to a vertex point. And then a sphere. Which has no faces, edges, or vertices, just kind of all that curved edge around, kind of like a ball. So let's go ahead and name these based on the shape of the base. So we can see this base here, and this base here is a triangle. So it is a triangular prism. Then we have this one here, which we would call a square. And we'd, of course, have a little more detail of the fact that those are all, but square prism. Here we have that pentagon-shaped base, so it is a pentagonal prism. And then here we have the triangular pyramid. And then here we have the square pyramid, or rectangular, but we'll go with square. And then here we have the pentagonal pyramid. So we kind of look for its base shape, which is not only important in naming, but also in its formula. If we look at our different formulas, they have a capital B, and that is the area of the base. So it depends on what kind of shape the base is to find its area for most of these figures, especially ones that have like a prism and pyramid where their base changes. On a cylinder and cone, we know the base is always going to be circular, but that base is going to change, and that's a part of its formula. A net is a three-dimensional figure that when folded forms the surfaces of it's a two-dimensional figure that when folded, it forms a three-dimensional object. So this, if it were kind of to curve around and it's got that circular base, this would come to a point and it would form a cone. And this, if it folded all up, it would become a cube. All right, lastly, we're going to talk about area of a sector. So here is our formula where we are going to put our angle or degrees over 360 times pi r squared. So the formula for area of a circle, and then our portion of what we're kind of using. So we are going to take 45 divided by 360, timesing it by pi times 6 squared. So in our calculator, we're going to go ahead and do in parentheses the 45 over 60, and that gives us 0.125, and then we're going to take that times 36 because that's what 6 squared is. And this is the 4.5 pi, that's our kind of exact answer. And then if we put that into our calculator and times that by pi, we get approximately 14.1, and that is yards squared for the area of just that little section there, that little slice. This next one is going to be 300 divided by 360 times pi times 11 squared. So again, 300 divided by 360, and then we're going to take that times 11 squared, and that is going to be well, it's not exact, but 100.83 times pi And I guess I could give that to you kind of as a fraction. It'd be 605 divided by 6. But anyways, we're going to times it by pi anyway and get about 316.8. And that is centimeters squared for the area of kind of that section there.